Alright, in this video I'm going to discuss how to do an ANOVA test, and I'm going to do it both with the data analysis toolpak, and if you don't have the data analysis toolpak, you can do it by hand, or not necessarily by hand, but like using Excel without the toolpak. Okay, so first off, what is an ANOVA? An ANOVA, we have a null hypothesis that all the means between the different groups, so it looks like I have test scores for fall, winter, spring, and summer. So these are students' test scores. And the null hypothesis would be that all the means are the same. So the means for these 4 different groups are all the same. Okay. The alternative hypothesis, HA or H1, would not be that they're all different. Okay, they don't all have to be different, but at least one of them has to be different. So at least one mean test score is different. Okay, so could just be that yes, the winter is different than all the rest. Could be that winter is different than fall, which is different than spring, which is different than summer. They could all be different, sure, but at least one of them has to be different. Okay, so this is our null and alternative hypothesis. Okay. So first thing, if you want to run this ANOVA and you have the data analysis toolpak, go to Data, and then Data Analysis. Scroll, look for ANOVA, and this is a single factor ANOVA. Press OK. Okay, if you already have stuff in there, delete it. Okay, so the input range, make sure your cursor's there and it's nice and empty, and then highlight your data. Now notice I did highlight these labels here, but I didn't highlight the test scores. Okay, so you can only take one label. So that first, this row 4 has the labels in it, and it'll use that, but don't highlight more than one label, okay? So more than one row. Okay, how is my data grouped? Okay, remember, these are rows and these are columns. So it looks like I am grouped by column, okay? So it's grouped by column, good. I have a label in my first row, okay, you should. And then alpha, I'm going to use type 1 error rate of 0.05. That's good. Output range, if you have anything in there, delete it. And then I'm going to put it right there. Okay, so all my output's going to be right here. Okay, press OK. Okay, so let's see what it gave us. So these are my different groups. I have 15 observations in each group. This is the sum of all the data, this is the means of all the data, and this is the variance of all the data for each group. All right, then we have these are sum of squares. So sum of squares between, sum of squares within. And I'm going to show you how to calculate these, okay? But basically, if you were to add up these two sum of squares, you get the total sum of squares. For right now, I do want to point that out to you guys, that the sum of between and within equals... So actually, when I highlight both the data, you see it down there at the bottom. So this sum equals the total. Okay, same things with degrees of freedom. This degrees of freedom, again, I'll talk about this a little bit more in a minute, but basically the between groups is the number of groups you have minus 1. And within groups is the number of observations that you have. So here it looks like I have 4 times 15 observations, so that's 60, minus the number of groups that you have, so 60 minus 4. Okay. The mean sum of squares is the sum of squares divided by the degrees of freedom, and then the F score is these two MS's divided by each other, and the p-value, which is that's actually one of the most important things here. Of all this, everything we have, this p-value, let me highlight that. That is going to tell us what we should do about our hypotheses. So this p-value is large, right? It's more than alpha. It's more than 0.05. So since we have a large p-value, we are going to fail to reject the null hypotheses, and we're going to conclude that there's not enough evidence to suggest that at least one mean is different. Okay, so this p-value is larger than 0.05, so we failed to reject the null hypothesis. Okay, all right. An assumption you need to have in order to run an ANOVA is that you do need the data to be normally distributed. So for each group, they need to have the normal distribution. Okay. All right, so that's how you do it in Excel using the data analysis toolpak. Very nice. If you don't have the data analysis toolpak, we need to calculate each of these guys. We basically need to construct this table. So let's talk about how to do that. First thing that I want to do is calculate my group means. All right, group X bar, we'll call it that. So equals average. Okay, open parentheses. Okay, highlight your data for the fall. Okay, and we see that on average, the fall students are scoring an 85.667. Okay, making my cursor into this black cursor by getting it right there in the corner and dragging it across. And I get my averages for all 4 groups. Okay, so this is what I'm testing. This is my sample averages, and I want to know, is the population average, are they the same? Or is at least one of them different? Or is it just due to random variability that they're looking different here? Okay. So let me highlight these guys. Okay. All right, so those are my group averages. Next thing I want to know is what is the average for all of my data? So total average, total X bar, equals average, open parentheses, and highlight all the data. Close parentheses, and press enter. Okay, so this is my total mean for all of my data. Okay, I also want to know the sample size for each group, which, I mean, I know it's 15, right? But let me go ahead and do it. I'll call this group N. Group N. N stands for sample size. So equals count, open parentheses. Okay, highlight my data, close parentheses, press enter, and I have 15. Okay. All right. I have everything I need now to calculate my sum of squares between. Okay, so SS between, so that's this guy. That's the first one I'm going to calculate. So this is going to equal, okay, 15 times, open parentheses, take your group sample mean and subtract off the total sample mean, and then square it. All right, so your sample size, the group minus the total squared. Okay, press enter. And do that for all your groups. So 15 times 77.113 minus the total second squared. Okay, and I could just keep on typing it in like that. 15 times, open parentheses, don't forget your parentheses. So 83 minus total second squared. All right, another thing that you could do instead of typing it out each time is you can use this like lock function. So this $sign will lock this B21. So you always want to be subtracting off the total mean. And then when I take my cursor, get that black cursor and drag it, it'll keep it there. Okay, so good. So the total sum of squares is just going to equal the sum of all these. Close parentheses, press enter. And what do we get? Very good. They're matching each other. Let me use a different color. I'll use green. Okay, so our sum of squares for between, that's how you do it. So what we did was we did the n sub I being maybe for the group, times x bar I, right? So the group x bar minus the total. Instead of writing x bar, let me write mean squared. So that's what we did. So the ith mean minus total mean squared times the sample size of that group. Okay. All right. Now, that's sum of squares between groups. To find the sum of squares within groups, let me see. I need to create basically like another table like this one. So I need to calculate. What I'm going to do is actually insert some cells here. Okay, so what I need to do is I need to take every observation and subtract it from its mean and square that difference. So starting with this first observation, have a parentheses. Okay, take that observation minus its mean. Okay, second, square it. So it's difference between the observation and its mean. Okay, the group mean. Now, I want to lock that 20. So I press that little $sign in front of the 20. Okay. So then when I scroll, get my cursor into the black cross, and I scroll it all the way down, see each of these this is this one minus that one. So the B20 got locked. Okay. Okay. Highlight this. Get your cursor to be that black thing, black cross, and scroll it over. Okay. So you see each one of these is the difference between the observation and its mean squared. If you click anywhere, you should see the difference between observation and mean squared. Okay. Okay, and then the sum of squares within equals the sum, open parentheses, and then highlight this entire table that you just created. Okay. Close parentheses, press enter. And we get that. Right? You see it's exactly the same as the sum of squares within that was calculated by the data analysis toolpak. Okay. So let me take this and make this look like a chart. All right, good. So now I'm most of the way there through this chart. That was definitely the hardest part. Figuring out if you have your sum of squares, now you're good to go and calculating everything else. So the degrees of freedom for, actually let me take this and let me make this chart look exactly the same. So I have my sum of squares, and I have my between, and I have my within. Okay. So I'm making basically the exact same chart that we're seeing that Excel made. Okay. So the degrees of freedom. Degrees of freedom between is always just your number of groups minus 1. So I have 4 groups, minus 1 is 3. Okay. Within, it's the number of observations that you have minus the number of groups that you have. Okay. So how many observations I have? I have 60 observations because there's 15 times 4. So 16 minus, and then I have 4 groups. Okay, 56. Okay, that's my degrees of freedom. All right, and of course I can also be calculating a total, and the total is just the sum. So if I sum up between and within, that's my total sum of squares. Equals sum. Okay, and you should always have here the total degrees of freedom should always be total number of observations minus 1. So 60 minus 1. Okay, it's a good way of checking to make sure that you did your degrees of freedom calculations correctly. Okay, mean sum of squares, MS, equals the sum of squares divided by the degrees of freedom. Okay, so let me do that cell work. Equals, so the sum of squares, that guy, I just clicked on it, divided by the degrees of freedom. So I just clicked on it. right? So I could have written 655.7833 divided by 3, but why do that? Just use your cell references by clicking on it. Enter. Okay. Equals sum of squares divided by degrees of freedom. Just click on it and press enter. Okay, so that's your mean sum of squares. Next we have our F. F is just equals the between divided by the within. Okay, just click on those cells. That way you don't have any rounding error as well when you just click on the cells. Okay, lastly, our p-value. Okay, so this is an F-test. So we want to use f.dist.right-tailed. Okay, x is the f that we just calculated. Okay, that little f, x, comma. The degrees of freedom for the first one is the between degrees of freedom, comma, the within degrees of freedom, close parentheses. Okay, so the f value, the between degrees of freedom, the within degrees of freedom, close parentheses, and press enter. Okay, and you should see that that p-value is exactly the same as the p-value that the Excel would have given you. And we do. Very good.